Alright, so in this video, I'm going to be solving the equation x to the power of 3 is equal to phi to the power of x. Now, to solve this, I'm going to first start by using logarithms. And if you don't know what logarithms are, I recommend watching a video on them. But what I'm going to be using is the natural log. And I'm going to take the natural log on both sides. So I have ln x to the power of 3 is equal to the ln of phi to the power of x. Now from here, if I have something in the form ln a to the power of b, I can move b to the front. So this turns into b times ln a. So in this case, I can move 3 to the front over here and x to the front over here. So now I have 3 times ln of x is equal to x times ln of 5. Now, what I'm going to do is divide both sides by 3x. So this way, for my left-hand side, these two cancel out, and for my right-hand side, these two cancel out. So now, all my terms with x I have on my left-hand side, and all my normal terms I have on my right-hand side. Now, I'm going to bring in something known as the W-Lambert function. And what the W-Lambert function states is that if you take the W of something in the form a times e to the power of a, this is equal to a. So, in this case, for my left-hand side, I'm going to write this as 1 over x times ln x. And now, 1 over x here is the same thing as e to the power of ln of 1 over x. And now this 1 over x is the same thing as x to the power of negative 1. Now from here, I can move the negative 1 to the front. So I get e to the power of negative ln x times ln x is equal to ln 5 over 3. And finally, I'm going to multiply both sides by negative 1. So I get negative ln x times e to the power of negative ln x is equal to negative ln 5 over 3. And the reason I did all of this is to get this in the form a times e to the power of a, and which now it is. A in this case is negative ln x, so I have negative ln x times e to the power of a, which is again negative ln x. So now I can take the w on both sides. So now the value of a is in this case negative ln x. And by the way, this is also supposed to be you have to take the w on both sides. But now I have negative ln x is equal to w of negative ln 5 over 3. Now from here, I'm going to again multiply both sides by negative 1. So now I get ln x is equal to negative w of negative ln 5 over 3. Now, I'm finally going to take e to the power of both sides. So I have e to the power of ln x is equal to e to the power of negative w of negative ln 5 over 3. And e to the power of ln of something is just that. So these two cancel out, and I get x is equal to e to the power of negative w of negative ln 5 over 3. Now, this is the same thing because this is a negative exponent here as 1 over e to the power of w of negative ln 5 over 3. And from here, what we're going to do is this is actually not a real solution. But going back over here, we have 3 times ln of x. And the actual form of this is 3 times ln of the absolute value of x. So what we're going to do is we're going to count for the negative value of x. What we did over here is we accounted for the positive value, but we can also account for the negative value because this is the absolute value. So because this is not a real solution, let's see if there's a real solution with a negative value. So now I have 3 times ln of negative x is equal to x times ln of 5. I'm going to go ahead and divide both sides by 3x. So I have ln of negative x over x is equal to ln of 5 over 3. Now, this is the same thing as 1 over x times ln of negative x is equal to ln of 5 over 3. Now I can multiply both sides by -1. And now, I'm going to rewrite this again as e to the power of ln of -1 over x times ln of negative x is equal to negative ln 5 over 3. Now this is the same thing as e to the power of ln of negative x to the power of -1 times ln of negative x is equal to negative of ln of 5 over 3. And I can move this -1 to the front. So now I have negative ln of negative x times e to the power of negative ln of negative x is equal to ln of 5 over 3. And now if I take the w on both sides, I'm left with negative ln of negative x is equal to the w of ln of 5 over 3. And if I take e to the power of both sides, I get x is equal to negative e to the power of negative w of ln 5 over 3. And the thing about this is this has no real solution.